text and code embeddings by contrastive pre-training. We're gonna take a look into this paper. So contrastive means there will be lots of positive examples and negative examples, and that's how the pre-training will be done. So let's take a look. I will also feed this paper into Mistral, maybe also into Gemini. Look at the key mechanisms, what they are proposing. Looks like an encoder here, maps input X to embeddings, then doing cosine similarity, Bx, By. So we're going to take a look into this and also look into the comparisons and test results. Also related works and feature works. We're going to take a look into all of these things. Alright, so the key mechanisms: contrastive learning objective. The model is trying to pull together embeddings of similar pairs and push apart embeddings of dissimilar pairs. Example: for text, consider two sentences. The cat sat on the mat and the cat was on the mat. These are semantically similar and would be considered a positive pair. In contrast, the cat sat on the mat and the dog played in the park. These are dissimilar and would be a negative pair. So model architecture, as you have seen already, there will be an encoder. A transformer encoder uses to process the input text or code and generate embeddings. Special tokens like SOS, start of sequence, EOS, end of sequence are added to the input sequences to mark the beginning and end. Then embedding instruction, the hidden state corresponding to the end of sequence token is used as embedding for the input sequence. So the training data consists of text embeddings and code embeddings. On paired text data, where neighboring pieces of text on the internet are considered positive pairs, and code embeddings, where the text is a docstring and the code is the corresponding function implementation. So text code pairs. In batch negatives, for each example in a mini batch, the other example in the batch are used as negative examples. Batch size, larger batch sizes are crucial. Okay. Initialization, pre-trained models. The models are initialized with pre-trained language models. So GPT for text and codex for code are used as pre-trained models for initialization. Okay. So let's look at the result. Effect of batch size. Larger batch sizes lead to better performance. Okay, due to increased number of hard negatives. Training behavior. The performance on search and classification tasks improved with longer training, while the performance on sentence similarity tasks decreases. Interesting. The model may be optimizing for different objectives in different tasks.